molar mass tells us how many grams is in 1.00 moles of a substance. So 1.00 is basically just 1. So the molar mass tells us how many grams is in 1 mole of that substance. Okay, simple enough. And so today we're going to work on converting between moles and mass. And our ratio for the day, our single ratio is going to be that 1 mole of a substance is equal to the molar mass of that substance. Another good ratio from back in the day was like 1 minute equals 60 seconds. Do you know where this is going? Let me review you on a concept that we haven't seen in quite some time that's called dimensional analysis, but close. Convert this number of seconds, what's that, like 4,768,300 seconds, to days. Y'all remember doing problems like this, right? Back a couple of months ago. What number is going to go in the top left box of our dimensional analysis chart? 4,768,300. Going to draw the line. Do this little guy. What unit has to go in the bottom right box? Seconds does. For what purpose? So we can do what with it? So we can cancel it, right? So seconds is on top. It's got to be on bottom in order to cancel it. How many seconds are we talking about here? And that's the number of seconds in. Now if we were just wanting the number of minutes, we could stop, but do we want minutes? Okay, so we want days. So tell me something about minutes. Should I put my 1 hour on top or bottom? Because I want my minutes to cross out. Correct? And I need to do one more. That's with 24 hours in one day. Should the 24 go on top or bottom? Yeah, because there's 24 hours in one day. That's going to allow the hours to cross. And you remember what we do at the end now? Perfect. You multiply all your top and divide by the bottom. Perfect. 4,768,300 times 1 times 1 times 1. I got something like 55.18 something. And I'll tell you what, let's go ahead and write down just the entire answer, 55.1886741. It's a long number, but that's what my calculator says. If you don't believe me, I'll show you. Told you. So, it's there. Does anyone need assistance with multiplying this 4,768,300 times 1 times 1 times 1? Well, it's just the same number. And then you divide it by the product of these three. The product means the multiplication of those three. Right? And this is what I got. Now, pull this back out of our hat. This will be the last thing we need to review from back in the day. How many sig figs are in the original number? 5? Those two zeros don't count, right? How many should be in our answer? So the 5, the 1, the 8, and the 8. Can my 6 bump this 8 up to a 9? So the answer is, this final answer, we're done now after this, 55.189 days. Y'all remember how to do that, right? About 9 weeks ago, give or take, a day or two. So let's zone back into this concept, not with seconds and days, but using this ratio up here. Isn't this a ratio that you see right there?
Yeah.
That's a ratio too, right? So is this one? Well, this is a chemical ratio. So we'll go with it. I'll show you how to do some of these problems. Let's look at one example. Example 1. That's what we'll call it. After this, we'll go to example 2. Let you write down this one real quick. We'll solve it. What I think we can do is we can identify that we're going to use a ratio. We're going to use this ratio, the molar mass ratio. Can I find the molar mass of sodium sulfate? Yeah, that I can. So that I'm basically saying, can you still do what we did yesterday? Can you? Yes, you can. What is sodium? What's its charge? +1. You'll see that it's an ionic compound. Sulfate is SO4. 2 minus. Bring our little numbers down. Na2SO4. Right? Now, can you find me the molar mass of Na2SO4?
Yeah.
Just to review us, let's work through it. How many NAs do we have? So that's 2 times 22.990 plus 1 sulfur, 32.066. Plus 4 oxygens times the value of 15.999 because that's the value of each oxygen. This isn't magic that we got going. These are numbers from the periodic table. Don't believe me? Okay. They are. 16 times 4, 15.99 times 4. Did we get something like 142? That's what you got? About 142? Now this is the number of grams in 1 mole, right? That's the molar mass of it. So this number right there, that 142.042, is the number of grams in 1 mole. So I think we'll be able to use that to our advantage. Do you see how we're using yesterday's stuff to get started today?
Yeah.
Okay. What's the number they gave us? Perfect. That's grams of Na2SO4, right? What unit should go on bottom? Grams, right? Of Na2SO4? Let's go and put that down there then. Grams of Na2SO4 should go on bottom. Do I know the number of grams of Na2SO4 in 1 mole of Na2SO4? Just found it out, right? Just wrote it down. So there are 142.042 grams of Na2SO4 for every 1 mole of Na2SO4. We solved this problem, right? Multiply this by 1, same number. Divide it by 142.042. Why don't you write that out real quick? Take 478.91 divided by 142.042. Let's see what you got. How many? I can have 5, right? The original 5 right there I can have. Okay, so that's going to be 3.3716 moles of Na2SO4. Good? Yeah, you need to say what unit you have, which is moles, and what you have, Na2SO4. Cool? Good stuff, right? Let's look at a different question. I'm going to let you a little bit on your own this time, though. So you're going to be on your own. How many grams of, I'm sorry, I should have said, and I want to say, how many moles? Let me try something a little bit different. How many moles of aluminum sulfide, that's aluminum sulfide, are in 713.8 grams of aluminum sulfide? So I want you to take your grams of aluminum sulfide, and I want to figure out how many moles are in it. The answer here. So tell me by a show of hands, who got this right? Awesome. Which was this even the same problem or style as before? Was it?
Yeah.
It was? What kind of? Was it? Okay, yeah, it was. So we just found the molar mass, right? Take our grams divided by the molar mass, get our moles. Straightforward, right? Okay. I'm gonna change it just a little bit. I want to see how this one goes as well. So I'm gonna get you to write this one down. Work with someone around you if you need the assistance. I want you to try to figure this one out. No. No. 1 grams. How many grams this time, and I mean grams, of zinc 2 chloride, of course I'm giving you the 2, zinc is always 2 plus, do I have if I have 4.83 moles of it? So let's take some moles now and let's go maybe a reverse direction. I want you to try this out, I want you to see what you get. Let's say maybe 2 minutes. As you can see from this example that we had just done, you can be asked to go from moles to grams or grams to moles, right? So I'm going to give you another problem. Bless you. So if I was told that I had a bottle of water that had 7.83 moles of water, how many grams did I have? So let's take that moles of water that's been provided and let's find the number of grams that that would have in it. In this case, what's my starting unit? Moles, how many? 7.83 moles of H2O, right? That's got to go on top. For sure, for sure. What unit's got to go on bottom? Moles of H2O. There should be no doubting that. Now my conversion from earlier today we saw was that it's always 1 mole is equal to what? Your molar mass, right? That was our conversion for today. 1 mole is always equal to molar mass. So how many moles do I got? Just said it. Definitely got 1 mole. 1 mole of any substance is always equal to its mass. So what's the mass of H2O? 18.015 grams of H2O. Perfect. 7.83 times 18.015. How many sig figs can I use? 3. 3 from the original number, so I think that's about 141 grams of H2O. Good stuff? Would you like to see one more example, or are we good? Maybe one more? There was 78.3 grams of carbon monoxide in the container. How many moles do we have? MOLS and MOLES, it's kind of the same, moles. Let you write this down real quick. I think it always helps to underline what you got in the problem as far as your starting amount. This is pretty simple, 78.3 grams. Really not much of a deviation here. Can we find the formula of carbon monoxide? Is that covalent or ionic? So I'm going to use my prefixes and get just CO out of it. What's my starting amount here? 78.3 grams of carbon monoxide. So am I going to put my grams on top or on bottom? On bottom. You can always do this step first because you know if it's up top, it's got to be on bottom too. Now, the ratio that we learned today, again, was that 1 mole is equal to the molar mass. So am I going to put my 1 mole, because you'll notice that number in front of mole is 1. It's always 1 mole for at least this molar mass concept. Should I put my 1 mole on top or on bottom? Top. I've already got a unit here of grams. I can't replace grams with moles, so 1 mole has to go on top. And 1 mole of any substance is equal to what? The molar mass of that substance. You can see that this thing that we wrote down, like 3rd line in on your notes, is pivotal for today. Now how can I find the molar mass of CO, carbon monoxide? Add it on the periodic table. That's 12.011 plus 15.999. Should be about 28.01 grams of CO. Are we 100% clear on where this number's coming from?
Yeah.
This isn't crazy stuff. This is just periodic tabled. Do we get why I put grams on bottom? Do we see why it's different? It's like once the molar mass is up top here, but it's on bottom here, right? We all go home at the end of the day, do we not? You take the same street to get home as you did to get here, most likely, I suspect, right? But are you driving down the same pathway? You can't be, because you can only drive on the right side of the road, correct? So we're using the same conversion factor. We're using the same principle, the same street name, but we are going opposite directions. Same concept. Multiply 78.3 times 1, which is still 78.3. Divide it by 28.01. Keep your 3 sig figs as you're required to. So I got 2.80 moles of CO. Moles of CO. Good?